Do you trust artificial intelligence? More than that, do you trust a machine to drive your car? By 2025, over 20 million fully autonomous vehicles will be on the road. By 2021, connected car technology will have a $140 billion market. However, 75% of Americans are afraid to ride in a self-driving vehicle. So what is our solution? If AI in cars was more intuitive to human emotions and therefore acted more naturally, the passenger would be able to trust and enjoy an autonomous vehicle. How do we do this? By using biosignals such as brain activity, eye movements, or facial expressions. We can build a picture of a passenger's psychological state and reaction to his or her car. We can then use this information to train the AI with deep learning to adapt its behavior to make the passenger more comfortable.
Hi, I'm Samir from Team Braiq, here with Victor and Sona. We at Braiq are intending to build a brain-computer interface for the smart car. From what you heard, our technology may sound fanciful, but rest assured we have the technical expertise to execute on that vision. Our team, based out of the Biomedical Engineering Department of Columbia, has pedigree in several disciplines, like computer science, neuroscience, electrical engineering, and biomedical engineering. We have more than a decade of research experience building brain-computer interfaces and have incubated 2 neurotechnology startups in the past. We hope to be the third. When we came into Combine, we had a cool technology and a rough idea how this could be valuable in the market. But after conducting more than 70 interviews with people in the car business, attending a connected car conference in the Bay Area, and doing requisite coursework, we are pretty confident that our business has legs. And that's because we learned a lot. When we came in, we thought that our focus should be on major car manufacturers like Ford, GM, Tesla. That personalization of ride in fully autonomous cars was our core value proposition, for which EEG sensing was vital. And that licensing to entities such as Tesla would be a walk in the park. But after talking to people in the car industry, we realized that a lot of our hypotheses were wrong. First off, we realized that the car business is very hierarchical in nature, with several tiers of suppliers. And these suppliers are important. In fact, 2/3 of all research dollars spent last year were spent by the suppliers. And that's a pretty big pile of money because car industry spent over $100 billion for R&D last year alone. We also realized that we need to be smart in how we sense data from humans, that our technology cannot get in the way of experience. We also learned that we can retool our technology to solve a near-term problem in the semi-autonomous vehicles. When your robotic chauffeur has been driving for a couple of hours and it asks you to take back control, you're cognitively not ready to do so. In fact, it can cause accidents. Therefore, determining the timing and optimal exchange between man and machine is vital for safety. Most importantly, we realized that relationships are important in the car industry. That to get revenue, we first need to execute several co-development projects with entities, develop their trust, and entrench ourselves in the ecosystem. Only then we can hope to see our technology in production cars. With these lessons, we updated our ideas to reflect the voice of the market and also developed a viable business plan. In the first few years, while the connected car or the autonomous car technology is being incubated in the car industry, we are going to partner with several entities. We're going to do co-R&D projects with them and try to add to the list of our partners. Hopefully, over the years, by these projects, we are going to develop an IP stack. Once this technology matures and goes into production, we can hope to license our algorithms and data to the car manufacturers. But there are also various risk factors. The most important risk factor is that the quality of data from existing sensors may not be good enough to satisfy the stringent quality standards of the car industry. There may also be regulatory hurdles and privacy concerns. Perhaps we are not able to have multiple partners at the same time because of conflict of interest. We hope to resolve these issues in the future. So where are we right now? We can validate our fanciful technology in the lab, as you can see in this video demo narrated by Victor.
At Braiq, we have implemented our ideas into a working prototype of a self-driving car informed by passenger state. In this demo simulation, a passenger uses virtual reality to experience an autonomous car while it follows another car. As the car drives through the environment, the passenger may see objects at the side of the road that captures his attention. In this clip, you can see a demonstration of how the autonomous car has learned to follow another car just by understanding that it needs to avoid crashes. It successfully avoids a crash when the lead car brakes and continues to follow at a reasonable distance so it does not lose sight of the car. However, this AI is not in tune with the passenger, so it ignores the objects at the side of the road, and the passenger can only view them briefly. To inform our AI that the passenger may want a better view of an object, we use brain signals from the passenger to let the car know which objects he is interested in. This encourages the AI to keep those objects in view during a drive. These brain signals stem from naturally occurring reactions, so the passenger provides information passively as he sits in the car experiencing the ride. The resulting AI can be seen here trained on two types of objects in the simulation. In the left car, the passenger wants to see furniture, and in the right car, the passenger wants to see desserts. When it approaches these objects, the car slows down to allow the passengers to view their respective objects at a relaxed pace. These objects are highlighted in the video so you can see them clearly as they are approached. As you can see, by using different passenger brain signals to train the car's behavior is modified to best suit the individual's preferences. This is just a glimpse of how we can inform a car about human needs. By customizing the car to the individual, we hope to personalize the driving experience and foster trust and acceptance in AI.
Next, we wish to take this technology out of the lab and convert it into something that looks like a viable consumer product. In the next year, we hope to leverage off-the-shelf equipment, such as an iPad for its camera, sensors and processor, Apple Watch for its biosensors, and also smart innovations such as soft EEG sensors embedded in the headrest so that we can inconspicuously sense your brain waves. Crunch all that data on the iPad and that make the psychological state be available to the car via Bluetooth. In summary, we at Braiq hope to connect AI and the mind. Specifically, we wish to make technology so that AI can learn from humans. Our immediate market is the $140 billion smart car industry, where our partners are going to be major car manufacturers such as Ford, GM, Tesla, and we hope to generate steady revenue using R&D contracts and more revenue in the future through licensing. Thank you.